All right, for the next couple questions, we're going to talk about this function right here. Carefully describe g of x as x approaches infinity and negative infinity. Well, let's just think about that. This function right here, what's happening as you go this way? Well, we have to think, what kind of function is this? Well, we look right here, e to the negative 0.4x. Well, that would be, consider e, we know it's continuous growth or decay. Since it's negative, we know it's decaying. So what we do know is this thing is a decay. There's an asymptote here, and we know it's decaying, kind of like that. All right? Now, we can use these to find some more information, which we will soon. But we know it is decaying because it's a negative 40% decay. And decays look like this. But now let's start over. This negative 3 throws us for something different. Oh, it normally would be decaying, but it's at a negative 3, so it's flipped. So no, it's not like that. It's actually going to be flipped over, so it actually looks like this. This is actually g of x. All right, you got to watch out for that. And our asymptote right here is y equals 5. Now, where to get 5 from? Well, this right here is your asymptote because it got pushed up 5. This right here is saying it's got stretched by 3 and flipped. So the red is not the graph. That's the graph before you flipped it. So it's actually this blue graph. So let's think about this. Describe g of x as x approaches infinity. Well, as you go this way forever, what is it doing? It's approaching the value of 5. So as x approaches infinity, what's happening is that g of x is approaching 5 because the y value, or g, is approaching this asymptote. Now, if we go the opposite direction, as we go this way, what's happening? Well, as you go this way, carefully describe, well, as negative infinity, well, let's write that one out. As x approaches negative infinity, g of x is approaching also negative infinity. A little bit weird there, but it makes sense because as I go this way, it's just drop forever, approaching negative infinity. Alrighty, next one. Carefully describe how g of x exponentially grows or decays. Well, the graph right here looks like it's growing, but it really is an upside down decay. It is a decay because this red graph is kind of what it looked like before it got reflected over y equals 5. So it really is decaying. So the first thing we have to realize is it is a decay. Second thing we have to realize is, well, as you look at this decay right here, let's talk about this one. This is just upside down. So let's talk about the red one. It just makes more sense. Okay? This is approaching 5. From both sides, it's approaching 5. So it's a decay that's decaying towards 5, either way you think of it. So it's decaying and approaching 5. Do you also notice that it's steeper and it starts getting less and less steep? As you get farther and farther right, it gets flatter and flatter. So the decay it's decaying at a slower rate as you go on. It's getting less and less amount of change. So be aware of that. So this is the decay, but it's slowly decaying, slower and slower, and less change happens over time. So let me say it one more time. This graph right here is decaying. It's an upside down decay. It's approaching 5. Now, it's not decaying at a constant rate. Yes, the rate is at a maybe like 30% or 20% or something like that. But what you have to realize is, let's look at this one, is it's dropping quick and then slower and then slower and then slower. So it's slowly dropping less and less as time goes on. And that is kind of important. So next, we want to find the x and y intercept of g of x. So the easiest of the two is a y-intercept. To find the y-intercept, we are going to put 0 for x. So I'm going to put 0 for x, and I want to find y. In order to do that, all we do is find g of 0, which when we do that, it becomes something like this. I'm going to put 0 right there. When I do that, what I get is becomes g of 0 equals -3, and anything to a 0 power, because 0 times that's 0, anything that's 0 is 1, so that's going to become a 1 right there, plus 5. And now I just simply do -3 times 1 is -3 plus 5, which that equals 2. So my answer is 2. This is my y-intercept. Boom. Right there. Next, we want to find the x-intercept. To find an x-intercept, we want to find the x value when y is 0. So we want to find now the x-intercept. So we're going to put y is 0. So we're going to put 0 equals -3e to the -0.4x plus 5. And we want to solve this for x. So the first step is minus the 5 over. That gives me -5 equals -3e to the -0.4x. Then I divide by -3, both sides. So I now have 5/3 is equal to e to the -0.4x. Now I personally like to rewrite this as follows. Before I make this into a log, I like to switch the sides. I like to move this to this side and this to this side. I like to switch sides. It just makes it easier for me. So this is going to be log base e. What's inside the log is going to be 5/3, and that equals to the -0.4x. So again, we put log right here, we switch these two, and we get this. Next step, we divide by the -0.4. We divide by -0.4, and that is my answer. So x is equal to ln, because log base e is ln, 5/3 over -0.4. So that is my answer if I did not have a calculator. That is my x-intercept. But if I find the value of that, x, in a calculator, x would be approximately -1.3. So I'd put -1.3 as my x-intercept if I had a calculator to calculate that. Let me describe this one more time. Just explain this so you have something in your notes to look at. Well, let's just say that g of x decays less and less as it approaches 5. See this, as it approaches 5, isn't it decaying less and less and less and less and less? And that is kind of important. It's not a constant decay. It is decaying less and less as it approaches the asymptote.